Hey there YouTube, this is SGM4306. I just want to make a very quick video. I was on eBay, as I do, and I was looking for like industrial, semi-industrial, non-consumer electronic modules, as I do. And this was about maybe a month, probably more than a month ago actually. About a month and a half. And anyway, I found this guy, and the seller was selling these for $50 free shipping, I believe, and make an offer. And to begin with, $50 for one of these is an absolute steal. But I made an offer, I think, for $30, and he obviously turned me down. That was, just me lowballing him. And we eventually settled on, I think I paid $45 or maybe like $42, something like that, low 40s. And so definitely happy with that. I probably, if he pushed hard enough, I probably would have just bought it anyway for the original price. But to show you what's going on inside here, well, first off, we have a dual rail power supply. This is a plus minus 15 volts. And you might be thinking, well, why the heck would you need a plus minus 15 volt supply rail? That's because there's some really interesting tech in here. So I'll show you guys the part that'll give it away last. So this is the part that won't necessarily give it away, unless if you know what these modules look like. Basically, we have a bunch of little trimmer caps that are preset at the factory. As Dave Jones would say, they were set by graybeards, with a adjustment tool with their tongues out at the right angle. Anyway, there's a little heat sink and some devices at the back here. Now, a little hint. There's some text here that says X and Y. Sorry, it's really difficult to see. So basically there's some sort of axes, and basically these are drive devices for some kind of inductive load, that kind of tells you. And there's lots of calibration pots, and they should be labeled here. Interestingly enough, they forgot to reverse the silk screen. But yeah, you can see some of it. Well, you can kind of make out what it is kind of now, hopefully. Anyway, this is a module 4, and this is the delicate part. We have some wires in here too. Nice that they included that. And hopefully that's not a bad sign that there's a hole in the side, because I will cry if these are damaged. Here we go. Very carefully remove this. Okay, good. That was just the connector poking through. Make sure as heck, I mean, these are rather dirty. I'm going to have to clean these off anyway. If you don't know what these are by now, these are laser galvos. So basically, set up a laser beam pointing, I'm not sure the exact orientation, but pointing coincidentally at one of these paddles, which will bounce it off the other one, which will bounce it out the front. So I'm not going to touch these anywhere near here. Don't want to damage the surface because it's essentially a very clean mirror that on a paddle that rotates very fast. And these, I believe, can do anywhere from 15 to 30 kilopoints per second. So these can essentially do very fine, small, accurate movements, and they flicker thousands of times per second. You can modulate them to create like laser light shows and stuff like that. But I have another idea for this. So anyway, we can just take a look at, there's a feedback mechanism as well as the drive mechanism, and it looks, I'm going to take a guess that these two thicker wires are the drive mechanism, and there's some like very thin magnet wire that you don't want to break leading out to two pads there, and that's probably the feedback mechanism. It's probably like either magnetic or capacitive feedback, and wires that'll lead to the main board here, and this is the controller board for it. And this requires plus minus 15 volts because it's essentially driving it, modulating it plus minus whatever degree deflection. And so I'm just going to set that down very carefully there. So yeah, so what am I going to do with this, are you asking? I'm probably going to make something crazy. First off, I'm going to make something very simple, just have it display simple shapes. And I dug out my old FPGA, and I'm going to go about teaching myself that again, the HDL and Verilog and whatnot. It's been years since I've touched my FPGA. So anyway, I'm going to get back into that, and I'm going to make something crazy. So I have loads of old Game Boys, and my goal is to create a Game Boy laser display, which sounds absolutely ridiculous, and it will be, hopefully. So hopefully these guys are fast enough that I can rasterize a display for a Game Boy. So it'd be 160 by 144 high pixels, and I'm going to have to pulse width modulate at a very fast rate, or do some kind of multiplexing trickery with the raster scan in order to generate the 2-bit grayscale color for a Game Boy. And I'm going to use a green laser, so obviously, black and green, sort of. Anyway, yeah, so it will be inverted probably because, laser's green, and then the areas that aren't lit up would be black, obviously. But yeah, this is absolutely insane. For like about $40, I think I spent, maybe a little more than that. But yeah, for less than 100. Usually when you see these guys go in the complete listings with like the power supply, the driver, as well as the galvos, usually easily like $100. So the fact that I got it for less than half that is absolutely amazing. So yeah, definitely gonna have to clean this. This is very dusty, I've noticed. But yeah, not a big problem at all. I'm very, very happy to have these. So I'm gonna make a quick little test program, probably with a PIC microprocessor and a digital to analog converter chip, so that I can just make like draw squares or something, just to make sure that the hardware all works. And then we'll get going with the FPGA to actually interface that with a Game Boy for the display output. So that will be very cool. Anyway, that's going to be a long-term project. That's going to take me quite a while to get up to speed on FPGAs, since it's been, I think the last course I took on FPGA architecture was in undergrad, so I don't want to say how many years ago. But anyway, yeah, so that's something to look forward to. And another thing to note, what's interesting is to drive these displays, the input to these this module here requires an analog voltage for the X and the Y. They're basically 3 pins on the drive input. And so it'll be plus minus 5 volts for the X and Y. If you put 0 volts in, there'll be 0 deflection. And then if you put a positive 5 volts in, it goes maximum deflection, and then minus 5 and it goes minimum deflection, like that sort of thing. So yeah, anyway, this will be very fun playing around with. I might just plug these in, and they should power on and stabilize to a fixed position, basically their start position. So at least make sure that everything mostly works up until I can get some actual digital drive circuitry in there. Anyway, hopefully you guys enjoyed the video, and if you guys are interested in getting these, I don't know if I can put up links if the seller still has these up, but I think he only had a low quantity, or maybe even just this one, and it might be gone by now. But I'll put up links if I find them. If not, I'll put up general search term links if you guys are interested in also picking one of these up. But yeah, look at that. It's absolutely stunning. And this is like solid aluminum too. Anyway, beautiful. I just wanted to make a quick video on that. So, ooh, can I see myself? See my eye. Hi guys. Anyway, hopefully you guys enjoyed this random quick video, and I will definitely have more on this once I get something going on this. And I'll see you guys in the next one. Bye. 3, 2, 1.